Next, stress concentrations. So as we discussed that, so these two materials, so if it is a regular composite material, those two materials are joined together. So one material tends to move, whereas the other material is not allowing to move, so that the stresses will be developed. Whereas here, it is allowing to move, and the thermal expansion or the interface is changing gradually. So from one portion to other, if you segregate into four portions, or if you consider this, the composition is varying from one location to other, so that the stresses will be reduced. So stress concentration are reduced if the transmission from one material to other material is gradual. If there is a sudden change from one material to other material, then the stresses will be high. Whereas, why? Because one material tends to move, the other is not allowing. So that internal stresses will be developed. Whereas here the stress concentration is less because of this gradual. The transmission is gradual. So it means the transmission is gradual from one material to other, so that the stresses are less. The magnitude of thermal stresses at the critical locations can be controlled. So the magnitude in the sense the values of the thermal stresses at the critical locations can be controlled. This can be tailored. This means the functionally graded materials can be tailored for specific application. So if we require toughness on one side, and one more refractoriness on one side, for that purpose we can tailor one functionally graded materials. So similarly, if you want the wear resistance on one more side and toughness on one more side, similarly, so we can tailor. So depends upon the application. These functionally graded materials can be tailored for specific applications. So depends upon the application, we can prepare different functional graded materials. Functionally graded materials are composite. So now the definition of the composite. So functionally graded materials are composite materials which are designed to present a particular variation of their properties. So FGMs are composite materials which are designed to present a particular variation of their properties. To get the desired variation of the properties, we are preparing functionally graded materials. So this is usually achieved by forming a compound of two components. So this is the preparation of functionally graded materials. This is functionally graded materials is usually achieved by forming a compound of two components. Those volume fraction. So here the volume fraction. Those volume fraction is changed across a certain direction. So if you consider this as volume fraction, the volume of material is changing across a certain direction. So if you consider the volume here, it is less, whereas the volume is more. So the black one is material 1. So white color, material 2. So the composition or the volume of black spots, the material 1 is increasing, whereas the volume of material 2, which indicates the white color, is decreasing. So from this direction to this direction, the black material 1, the volume of material 1 is increasing. So from this direction is increasing, whereas the volume is decreasing. Or vice versa. From one more direction, if you talk around this direction, that is vice versa. So one direction too. So usually, so volume fraction is changing across its direction, across a certain direction. Along with a certain direction, the volume fraction. So the volume of material 1 is increasing. So here the portion of black is less. It is increasing, furthermore increasing. So that the volume of material 1 is increasing. So simultaneously, automatically, the material 2 is decreasing. So the volume fraction is changed. So this volume fraction is changed along a certain direction. Next, for example, the toughness of a material can be mated with the refractoriness of a ceramic. So depends, if the material is exposed to high temperatures, those materials will be coated with ceramic materials. Why? Because ceramics are having good refractory properties. So as we know that for blast furnaces or for some furnaces, the outer steel portion, inside the steel portion is covered with refractory bricks. Why? Because to withstand the temperature, the refractory bricks are sticked to inside the chamber, so that the strength is supported by means of steel material, and the temperature withstand capacity can be increased by means of ceramic materials. So for that purpose, the steel chamber is lined inside with a ceramic refractory bricks. But the bonding between the steel and the ceramic is not good. So those two will be delaminated, depends upon the temperature. So the toughness of the metal can be mated with the refractoriness of a ceramic without any compromise in the toughness. So the toughness of the metal, we are not compromising the toughness of the metal as well as the refractoriness of the ceramics. So if we consider this as an example, so the functionalities, the structure of the material is varying from one portion to the other portion. So the atoms are having different microstructural. So those are having different microstructural phases, have different functions. So as we discussed earlier, so one side of the metal is having high refractoriness property and the other side is having high toughness property. So here, so depends upon the microstructural phases, those are having different functions. So the overall FGMs attain the multi-structural status from their property gradients. So example, so the body of the gear. So the body of the gear must be tough, whereas its surface must be hard and wear resistant. So the component, as we know that the gears are having n number of teeth, those are meshed with one more gear. So those two are meshed together. So these mating surfaces should have high wear resistance. If those are hard and having high wear resistance, the life of the component will be high. So if all the metals, the whole bulk metal are having the same wear resistant, high wear resistant, the material will be brittle. So that the inside, the whole component of the gear should be tough. Whereas the outer surfaces, the mating surfaces should be wear resistant. So both the properties cannot be attained by means of a singular monolithic material. So to overcome this, we are using these functionally graded materials. So depends upon the functionality, we are grading those materials. So on the bulk, so the whole bulk material is to be tough material, and the outer surface which are exposing to the other gear or which are meshing with the different material should have high wear resistance. Similarly, one more thing, the knife needs only to be hard at its cutting edges. As we know that, as we studied in MCMT, machine tools, metal cutting and machine tools. So the toughness, the hardness of the material, the tip of the metal should be harder than the workpiece material. So to machine a component, the hardness of the tool should be more than the work material. So here, the cutting tip, the hardness of the cutting tip should be higher. So as we know that the cost of the tool depends upon its hardness also. So if the hardness is high, the cost of the tool also high. So the knife needs only to be hard at its cutting edges, else where the material must be strong and tough. So the sharp edges are supported with some more material. Those materials should be strong for giving good support to these cutting edges. The cutting edge should have high hardness in order to avoid its wear. So to increase the life of our component, the hardness of the tool tip should be high and the complete body should be strong. So here, depends upon the functionality, it requires two different properties. One is the hardness at the tool tips and the toughness of the whole body. So these two properties can be attained by means of these functionally graded materials. So naturally available FGMs are bones, teeth, skin. So as we know that our skin is having one different property which can be withstanded when it exposed to the sunlight or at high high temperatures also. On the other side of the skin, it is supported with the blood flow, veins and all. So this skin is having a multiple purpose. On the outer side the functionality is different, and the inner side the functionality is different. That is the naturally made, functionally graded material. Similarly, teeth. So this is the schematic of the teeth. As we know that our teeth are ceramic materials. So ceramic metals are having refractoriness. So our teeth can withstand for temperature materials as well as cold materials, as well as these metals are stronger. So the outside ceramic, this enamel coating is our ceramic material. So the ceramic functionality, whereas this ceramic functionality is supported with the internal material. So that is the generally naturally made, functionally graded materials. Similarly, our bones also. So our bone, the calcium is surrounded with somewhat flesh. So the same, the functional, these are the naturally available, functionally graded materials. So synthetic materials, some examples are the steel and aluminum combination. Similarly, tungsten and copper combinations. So similarly, there are a number of materials. So depends upon our functionality. It means depends upon our functional properties. Those materials will vary. The combination will vary. But in earlier slides, we discussed that functionally graded materials can be tailored. So this can be tailored. So this in the sense, this functionally graded materials can be tailored for specific application. So depends upon the application of our composite, of our material. Those materials can be tailored. The properties, if we require refractiveness and toughness, or if we require hardness and toughness, if we require different properties, those all things can be tailored. So we can get different materials by means of these functionally graded materials. It means different applications for different purposes. So these two are some examples: steel and aluminum, similarly tungsten and copper. These are the applications of synthetic FGMs. Next, functionally graded materials. The properties of materials in functionally graded materials are not uniform. The properties of the material. So if we consider a monolithic material, it is homogeneous material. It means the complete, if we consider this as a monolithic material, the property at this location 1, location 2, location 3, location 4, 1, 2, 3, 4, properties at different location will be same. Whereas, so this is monolithic material or pure material. This is pure metal. So the pure metal, in pure metal the properties at different locations are uniform, whereas in functionally graded materials the property is not uniform across the entire material. So across the entire material the property is not uniform, and the properties, and these properties depends on the spatial position of the material. Depends upon its position of the material in the bulk structure of the material. Depends upon the position. So depends upon the composition variation, and depends upon the location where we are testing. So if we are taking the sample here and the position, if we are changing the position, depends upon the position the properties will vary. So location 1, 2, 3, 4. So depends upon the sample position, sample portion of the material, the properties will vary. Why? Because these FGMs are, the properties of these FGMs are not uniform. Next, FGMs are designed with varying properties that include changing chemical properties. So these FGM properties that includes having different chemical properties, having different mechanical properties, different magnetic properties, thermal properties, and different electrical properties. So along the composition, along the material, the properties of the material will vary. So it might be a chemical properties, it might be a mechanical, magnetic, electrical or thermal properties. It might be any properties. So depends upon the portion, depends upon the composition, those properties will varies. There are FGMs that are designed as stepwise gradient. So some FGMs are designed such that there is the graduation is stepwise grades, stepwise graded structures. So here like this. So here if we consider this, the composition from here to here it is uniform. From here to here it is uniform. This section, the same property along this complete section. So the FGMs are designed such that it might be a stepwise graded structures. So step to step, those are varying, or some are designed to be continuous, or some are designed to be continuous graded structures. So this is a continuous graded structure. So if we consider along a direction, the property is changing. Here the property is changing with respect to some steps. With respect to portions, these are varying. So with respect to steps, the property is varying. Here it is continuously varying. So it might be those functional gradient metals are designed as stepwise gradient. So it might be a stepwise gradient. Stepwise gradient structures, or some are designed for continuous gradient structures. Depends upon the area of application. So depends upon the application, it might be a stepwise or it might be a continuous one. Next, special features of FGMs. So special features of functionally graded materials. So FGMs, functionally graded materials, provide capabilities for part integration. Provides capabilities for part integration. Several metallic components can be replaced with a single FGM component. So for the desired purpose to attain the functionality, we are adding number of materials, number of components for satisfying for that application. So those all components can be replaced with a single FGM. So why? Because this is having a gradual composition. Variation in its composition gradually, so that many of the components can be replaced and the property can be attained by a single FGM. FGM provides capabilities for part integration. Several metallic components can be replaced by a single FGM. So to get the desired property, we need to use many components. Whereas, so many properties can be attained by means of single FGM, so that this one FGM component can replace many metallic components. So FGM structures provides in service monitoring or online process monitoring with the help of embedded systems, with the help of embedded sensors. So as we know that it's a combination of many metals. Due to this combination, the service of the component can be monitored, or online process monitoring can also be done by adding or by embedding by using embedded sensors. By incorporating sensors, we can track its service also. The matrix material binds the fibers together and transfers them. Next, advantages. So as we discussed that many metallic components can be replaced with single FGM, single functionally graded material, so that the weight of the component can be reduced. So reduced weight can be attained by means of this functionally graded materials. So next is low thermal expansion. So compared to that, so those two metals are having here also those two metals are having different expansion, but the composition is varying from one location to the other location, so that the overall thermal expansion of the component is less. Next, these functionally graded metals are having high specific strength, high specific stiffness. So this is the solution for incorporate material combinations. So material combinations, all material combinations cannot be possible in alloying. Why? Because due to its thermal equilibrium, those combinations cannot be possible. Whereas many combinations can be possible in these functionally graded materials. So here these functionally graded materials having ability to tailor the material for specific applications. So it depends upon the application, we can design different functionally graded materials. So that depends upon the application. So improve material efficiency. Next, improve part lifetime. So here due to its thermal expansion, so those two metals will be delaminated or separated from each other. Here there is a gradual interface so that the delamination or separation will not take place, so that the life of the component is high compared to regular materials. So next, drawbacks. So here the preparation of FGMs is an expensive technique. So expensive techniques, the process is high. So to produce an FGM component, the cost for manufacturing is high. So the next one is process is hard to control. So to prepare the component, it is very hard to control the process. Next, complex phenomena occurs. Complex phenomena like shrinkage, distortion, dilution, etc. These will occur during the manufacturing of this component. So these are the advantages and disadvantages of functionally graded materials. So functionally graded materials are designed to attain two different or two dissimilar properties on two different directions. So on one side of the component should have one property and the other should have different property. So it depends upon the application, these materials should have two different properties. So these two different properties can be attained without, so these two properties can be obtained by gradually changing the property along the composition or along the direction, across the direction of the component of the metal. Across the direction of the material, those properties can be attained, so that we can replace many of the metallic components with FGMs. Thank you.